Hi folks, so I've heard that going into Lab 3, there are some students that feel more confident working with the Excel functions than others. And so in order to put everybody on equal footing, I just wanted to put together this quick tutorial video on some basic functions that you can use Excel to help you with things like you're asked to do for Lab 3. So I'm going to put this spreadsheet online after I record this video, and it's going to have these demos encoded in it. So I've got a couple of tabs down here at the bottom. One of them I'm calling Fill Down and Count, which will be a demo where I can show you how to fill down a large number of rows without having to drag this little square and all the way down, which might be useful in that part 1 of the lab exercise, and then how to run some count aggregations on those the different functions for that, which also should be useful for part 1. Then I'll have this find maximum where we'll generate numbers on each row and then be able to find the maximum value of those numbers and find the position of it. And then something that I'm not asking you to do in the lab, but I did mention that you could do, is if you had a set of alternatives that are supposed to be generated with a certain probability, so a discrete probability distribution, so a finite or countable set of outcomes, how would you generate those? And I can mention in the lab lecture that you can do that, but I may not, if it's not so clear exactly how, then I'll try to do a little demo of that here. I also have a Scratchpad tab, which I've mirrored over here, so if I start typing in things here, then it should show up on the Scratchpad tab over here. And so as we start building formulas up, then kind of keep a cheat sheet all in one place here. All right, so let's go to the fill down part first. So in this fill down and count example, what I'm going to focus on is, like the first example, when you need to generate multiple columns of data through a huge number of rows. Now the traditional way, let's say I want to generate 2 random numbers per row. So I might do equals rand in one column and equals rand in another column. Now the traditional way you do a fill down, and then maybe I want to do some operation. So I might want to say, is this column less than this column? And it comes out that it happens to be true here. So then all 3 of these I'd like to fill down. Now the traditional way to do that is to grab this little green square and then pull all the way down here. And in like Google Sheets, you can do that as well. So it's not just a Microsoft Excel thing. Now, actually kind of an older way to do things, which is a little simpler when you have huge numbers of rows, is actually just to highlight the rows that you want to fill through, and then go up into the Edit menu and say Fill and then Down. And it will take whatever's at the top and then fill it all the way down through. So when you need to fill 10,000 rows, you don't have to grab this little green dot and drag it down until this counts to 10,000. One thing you can do, and there certainly are even simpler ways to do this, but I'm just kind of giving you a basic here, is to go down to whatever, find the 10,000th row or 10,000 rows down, highlight, wherever you want it to stop, and then say Edit, Fill, Down. And then it's done. All right, now, let's say I want to see how many rows I just filled down to double check, because I might have left some space here at the top. And so row 10,000 might not actually be the 10,000th data point. So if I want to double check that I did that correctly, what I can do is I can say equals count A, and then I can give it a column. And so I'll say B colon B. Notice that highlights the whole column. What count A stands for is count all. This basically says count everything except empty cells. So if I hit enter there, it says I have 14,096 rows. So that might be too many rows. So I could go down through here and say, well, all right, I didn't actually want 14,000 rows. So maybe I go down to, so I'll find, this is row 12,000. So maybe I find row 10,002. So because it looked like I had 2 extra up top, I might say everything from 10,002 on, I actually don't want. So I will just prune this. So I'll go down to the end of my data here, and maybe I can even overshoot and just hit delete so that now it looks like it ends at 10,001. Well, that might have actually been, maybe I actually did too far. Maybe I actually wanted to go down to 10,002. So now I could say, well, did I happen to fill those 10,000 rows? And now it says, yes, you actually counted up 10,000. And of course, there are other ways that we can do this. If I just click on column B and I look down here, it actually says count 10,000. So it already shows me there's a bunch of different ways that I can confirm that I've generated 10,000 numbers here. Now, what if I want to see of those 10,000, how many of these came up true? Well, I could do here count if, and then I can say I want to count how many trues are in column D. So I'm going to do count if D colon D to give me the whole column, and then I can put true here as my condition. And it says there's 5,028 that are in this column that are true. So if I want to know the ratio of those, I could just say I want this G divided by this F. And it says about half of them are true. And that makes sense because I generated a uniformly distributed random number here between 0 and 1, another one here between 0 and 1, and they're independent from each other. So it kind of makes sense that if I have two of them, then half of the time the one in the B column is going to be greater, and half of the time, the other half of the time, the one in the C column is going to be greater. So if I, every time I save a data point in here, it redraws all these numbers, and you can see this ratio gets updated too. And so as I type these things, these ratios always hang around 0.5. So just to summarize, I can say for the fill down and count example, what have we learned? We learned that if you go to the edit menu and then fill and then down, you can then fill down a huge number of rows without actually having to drag that thing all the way down. We've learned that equals count A and then a column identifier, so I could do like B colon B, will count all non-empty values in column B. And so it doesn't like that I put an equals there, so it's a little quote. And then we also learned that equals count if, and then I could give it a column identifier, let's say D colon D, and then true, will count all cells that have the value true in them. So then those two things together can give you a ratio of cells that meet the condition that you want. Now, the COUNTIF function can do a lot more than that. There certainly are a bunch of other ways that you can make this happen, but that is just one way that I'm saying that with those tips, you should be able to complete part 1 of the lab. All right, so for part 2 of the lab, this find maximum, so I'll put my tips here for the find maximum. We say that in each row, you might want to draw a couple of different random numbers. Now, of course, for this one, we ask you to do some arithmetic with these. So we're not just drawing random numbers. You're taking random numbers and you're scaling them so that they're bounded between different values. But I'm just focusing on how to find the maximum and locate its position. So in order for me to take the maximum of these things, I can just say equals max. And then I can just put in the location of all the cells that I'm interested in. So here I have 3 cells that I'm curious about, which one is the max. And so I can say this cell, comma, this cell, comma, this cell. And it shows me that this one here, 0.633, that apparently is the max. Now let's say I want to know which one of those. Is it B, C, or D? Or in other words, is it 1, 2, or 3 if you wanted to number these things? Now, there are a bunch of different ways to do this. If you have a whole lot of these, then I recommend you use some of the array functions and use some sophisticated arithmetic and indexing in order to make this work. But for the purpose of this lab, you can just do 2 nested if functions. And so you could do something like if this cell is equal to this cell, then we know that, let's say, column B is the one that is the maximum. Otherwise, that's what this other entry is here. We can say if this cell is equal to this cell, then we know that actually it's column C that's the maximum. And then finally, the else case here is just it must be column D that's the maximum. And so what we can see here, this just changed to C because C now is the maximum. What I could do is a little fill down here, so I can take this thing and drag it down a few. And we should be able to confirm that in every row here, like this one, 0.9, that's 0.9, that is the maximum, and it's column D, and it now reports column D. And so the syntax here is just a nested if. So for this find maximum here, what we've kind of learned is that we can do equals if, and then we can say, the if is going to be some condition, and then it's whatever the true value is, and then whatever the false value is. Or in other words, whatever the, we could say whatever the true value, or we could say value to report on true, and then we can say the second thing that comes after that second comma is the value to report on false. And you can do nested ifs. So you could do if condition and then value to report on true, and then another if condition, and you could say if and then whatever that condition is, and then value of true, and then value of false. So that's sort of the outline of how these ifs work. So it gave me an error because I'm trying to type it as a string. So in these, as one example here, I can, I could say, well, if, whatever column is my maximum, so F2, if F3 is equal to B3, then I might report B. Otherwise, if F, in this F23, that's supposed to be an F3. Otherwise, if F3 is equal to C3, then maybe I'll report C, otherwise I'll report D. And with that little formula like that, then you can get a column here where one column tells you the maxima, the other column tells you the location of them. And then, if I wanted to do statistics on those things, then I can use that count if. So let's say I combine the things that I just did before. So let's say I want to say, well, how many, I'll go over into column H here. So I can say, well, how many lines or how many rows actually have things in them? Well, I can use the count A function, and I can just arbitrarily, I'll choose column B, and it says I have 13 rows. Okay. And then I can go down here and create a similar thing counting up the number of C's. So I can say num C, so num rows that have C in them, and I'll use a count if, and I'll say, well, so column G, how many of them match the value C? And it tells me 3 for this group. And if I look down here, 1, 2, yep, 3 equals C. And so if I wanted to figure out the fraction of rows that had C, I could divide this by this. And so you can imagine doing that for A, B, and C, and that would give me the frequency distribution for option A, option B, and option C. So I've just shown you how to generate 3 random numbers and end up picking the max. And then from that, figuring out the index of the max, and then get statistics on how many rows have each index in them. So with that, you should be able to complete part 2 of the lab. There's a lot more arithmetic in getting all the paths set up, but that's kind of the most complicated part, is doing this max and then doing this nested if. All right, the last thing, kind of a bonus topic, is how to pick from a set. So let's say I had a set of options, say red, blue, and green. And I wanted red to occur with a 20% probability, blue to occur with a 50% probability, and green to occur with the rest. And so I could just actually do 1 minus, and then I'll do this plus, I'll do 1 minus, sorry, equals 1 minus, and then in parentheses, I'll do this column, or this cell plus this cell. So those finally add up to 100%. Now, in the lecture I mentioned that although this is the so-called probability mass function of these three outcomes, red, blue, and green, what I want here is the cumulative distribution function, and we will talk all about this in lecture. But basically, you should be familiar with the CDF from your earlier classes, but it's just going to be an accumulation of these probabilities. And so for the first value of the CDF is just going to match this value up here. And then the second value is going to be equal to the sum. Basically, it's going to be equal to the previous value here plus the value right above it. And if I were to fill right here, then I should get a 1 here. So the CDF it always starts at 0, which I'm not showing here, and then its first value matches the PMF value, and then it accumulates those until you get all the way up to 1. Now, why did I do that? Well, I did that because I now want to have outcomes that come from this column up here. I'm sorry, this row up here. So what I can do is I can say, well, I'm going to draw a random number, and it comes out to that random number here. And now I need to compare that random number to this CDF in order to figure out which outcome I want. And I'm sort of combining this. I'm going to use one of those if functions like I did in the previous example. So I basically say if this cell here, so I can say if B6 is less than or equal to this CDF value, B4. And what I'm going to do here is I'm going to use these dollar signs. So if you're not familiar with Excel, then what these dollar signs do is they basically make it so that if I fill down or fill left and right, it's going to leave these values as they are. So a lot of times when you fill it, if you move down a row, then it will think that you want all your row identifiers also to move down. Or if you move over a column, it'll think you want your column identifiers also to move over. So that's a relative indexing, but I want so-called absolute indexing, and so that's why I put these dollar signs in there. So I can say if B6 is less than this B4 value, then I would like to report this value up here, and I'm going to just put B2, which is red up here, but again I'm using this absolute indexing. Then in the else case, I can say, well, actually, if that's not the case, then if B6 is less than or equal to this value here, which is C4, then I'm going to report the C2 value. Otherwise, I'm going to report the D2 value. And you can imagine this nested if getting longer and longer with more and more options. And so we have 3 options, then it's just kind of that simple. And so notice all of the dollars here refer to things that come from this table, but I left B6 without the dollars, and that allows me to do a fill down. So if I were to highlight these two and pull down on them, then if I look over here, the B7 changed, but all the things with the dollars did not. So here's a B7, here's a B7, but all the things with the dollars stayed the values that they were, even though I filled down. I also want to point out that I drew the random number once and then referred to it twice. A lot of students, when they do this, a common mistake is to try to actually put the rand function inside the if multiple times. The problem with that is it will draw a new random value for this second one, and we really want this to be the same random number value both times. That's why we create a column of draws and a column of outcomes here. So in order to test my statistics out, I'm just going to take that and draw down a little bit farther here. And then I would like to just see if blue comes out 50% of the time like I'm expecting. So I'm going to count. So here I'd like to count how many values I drew down here. So if I use count A on the B column, the downside of doing that is it says there's 45 non-empty values here. But the problem with that is this is in the column B as well. So I can do a little modification where I can say, well, all right, then I'll also subtract off B1 through B5. And now it says there's 42 values. And if I just highlight down through here, yep, that's right, 42 values. So I have drawn 42 values down here, and I'd like to count how many. So I'm going to say how many columns or how many items in column C are blue. Now I have to again be careful because there is a blue right above it in column C, so I want to subtract off that one too. So from C1 to C5, I might also subtract off that blue. And so evidently I've done something wrong because it thinks that there's nothing that that matches the, oh right, of course this should be a count if, not a count. So it says there are 21 blues. So I can go through the excruciating counting here just to confirm that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that's correct. And look at that. 21 divided by 42 is exactly 50%. If I am not quite sure of that, I can just divide this one by this one, and then now the number's updated because I saved. But if I were to type in some random numbers here so that Excel draws new numbers, then I can see that very often this ratio sits around 50%. So if I wanted to duplicate that again, and I wanted to say, well, make sure that green is always 30%. Well, I can do this same thing. So I'm going to just copy that and replace the blue with green. With quotes around it because it's a string. And I can then also calculate that ratio. And look at that, about 30% of the values are green. So this example of drawing discrete values from a sort of a finite set here makes use of a lot of the tools that we used in this part 1 part and this part 2 part. And hopefully this is also a useful tool for you if you ever want to simulate drawing from a discrete probability distribution. All right, so the big things to remember for your lab 2 are these things here: fill, down, and count. Remember, you can go to Edit, Fill, and then Down. That's a little easier than dragging that green square. Count A counts any cell that is non-empty, and if you use the column identifier colon itself, then you get an entire column rather than just a small range. Count If is just like count A, except instead of counting non-empties, it counts any cell that matches the condition over here. And so you can put numerical conditions into there, and you can do that if you'd like to get more advanced. Or you can simply count trues or falses or count exact matches. For finding a maximum, you can use a little nested if, and that works great if you're only looking for across 3 values, because you can use the max function. So I guess I should put that out here as well. So equals max, and then a list of cells, like, so I could say cell 1, cell 2, cell 3, will end up giving you this here returns the maximum value within those cells. And so if I have that to compare to, then I can then say, well, is that max equal to a certain cell? And if it is, I can report the identity of that cell. Otherwise, is that max equal to another cell? And if it is, I can report the identity of that cell. Otherwise, it must be equal to the third cell. So with all of that, hopefully that gives you enough tools to be able to complete the lab and be successful. So if you have any other questions, feel free to post on the discussion on Canvas or send some of the instructional staff an email. Thanks.